All right, folks, we're doing summer assignment probability questions 4 and 5. So 4 is about flipping a coin 3 times. I'm just going to go ahead and say that coin flips are best as trees or lists. If you're really, really good at not missing any of the combos, you can do a list. If you feel like you're going to miss something, you might want to do a tree. So we're flipping a coin 3 times. I'm going to do a tree just to kind of show you how it works. So every time you split a tree, there's an event, and then you're showing the different outcomes. So this is coin number 1. So it could be heads, could be tails. All right, coin number 2. This is coin 1. Or flip number 1, either way. Okay. If coin number 1 was heads, it could go heads and tails. If coin number 1 was tails, this could go heads or tails. All right, and then coin 3 is going to be over here. Same deal. So coin 2, depending on which path it took, it's going to split into 2 because there's 2 different options. All right, so this is sort of time, and then every time you split is what could be happening, what are the possible outcomes before you do this event. All right, the one thing I'm going to say about trees is they're super nice and organized. The only thing I'm going to say is they're not really great at telling you the final outcome. So each of these splits has a chance of 0.5, right? Actually, I like fractions on these, but it happened. So the idea is that you want to travel a path through the tree and describe at the end how you got to this point. So this is going to be head, head, head. And the chance of this happening is 0.5 times 0.5 times 0.5, or half, half, half. So the probability of this particular event in this order is 1/8. That's the chance. All right. So I'm just going to collect how I got here in what order. So this is head, head, tails. This is head, tails, head. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. So when you flip 3 coins, let's go ahead and say this. When you flip 3 coins, there are 8 possible outcomes. We have them listed here. So this is the sample space. So if we just listed this, that would be sufficient. I'm just showing you how to get there, how to make sure you didn't miss any, and sort of showing you how to collect the probability. So each of these has a chance of 1 out of 8. The reason there's 8 possible outcomes is every time you do this, there are 2 choices, and you're doing it 3 times. So 2 options here, 2 options here, 2 options here. So that's how you get an 8. All right. So that's just kind of getting organized and making friends with this distribution. So next time you see 3 coins, you want to visualize this. Maybe you don't have to draw it, but you want to be able to replicate these guys somehow and get them written down. Okay, now, event A is, this is the thing we like, exactly 2 heads. Okay, so some of these meet that requirement. And then event B, 1 or more tails. So that's a lot of options. So I'm going to go ahead and list all the ways to get exactly 2 heads. The idea here is that one works. So head, head, tail, that counts. Head, tail, head. So if you got 2 heads, that means you got 1 tail, and you have 3 different places you can put the tail. It could be last, it could be middle, or it could be first. So it's 3 ways to do that. So we're listing the members of event A. There they are. That's part A. Event B, 1 or more tails. Well, heads up, guys. Only 1 that doesn't have a tail. So it's going to be everything except head, head, head. But we have to list them. So you're going to make a list. You're going to go HHT, HTH. This is fancy notation for I'm making a list. Heads, tails, tails. tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So every single thing in here should have at least one T in it. They do. The only one that, oh my gosh, the only one that doesn't is head, head, head. All right. So that is B. Find the union of the event A and event B. All right, let's talk about this vocab. This is vocab that comes straight out of Venn diagrams. All right. So